It is commonly believed that the mean body temperature of a healthy adult is 98.6 degrees Fahrenheit. You're not entirely convinced. You believe that it's not 98.6. You collect data using 55 healthy people and found that they had a mean body temperature of 98.29 degrees Fahrenheit with a standard deviation of 0.97. Use a 0.05 significance level to test the claim that the mean body temperature of a healthy adult is not 98.6. All right, so we want to test the claim that the mean body temperature is not 98.6. So the claim is the most important thing to identify first in a hypothesis test. We're testing a claim that a mean of a population is not equal to 98.6. Now, the claim being a mean tells us that we're going to either use the normal distribution or the t-distribution in order to calculate our statistics in the next step. For now, we just need to decide if this is going to be a null or alternative hypothesis. And since this doesn't have a statement of equality, we put it in the alternative hypothesis. If it had been mu equals 98.6, then it would have gone in the null. I'm going to mark that as the claim and put the complement, which is equal to, in the null. And that's perfect for the hypothesis. Now, what type of hypothesis test should you conduct? Left-tailed, right-tailed, or two-tailed? Well, because the not equals in the alternative hypothesis, that's going to be a two-tailed test. So if the alternative has a not equal, that's a two-tailed. If it's a greater than symbol, it's a right-tailed. And if it's a less than symbol, it's a left-tailed. And you can just think of these as like arrows pointing to the left and right, helping you remember which way that goes. All right, next, identify the appropriate significance level. So the significance level here is 0.05. When I make my comparisons, I'm going to change that into a percentage anyway. So I'm going to make it 5% significance level. Next, we will calculate the test statistic. And whatever kind of technology you use, that's fine. I'm using the TI calculator here. And if you're using something different, just make sure you know how to operate it to get the values you need. But those of you using the TI can follow along with me here. If you press the Stat button and go over to Tests, then we have a choice between Z-test and T-test. So we've already decided that we're going to use T-test. And stats are already, so we already have the stats from the sample and not the data. So we'll just keep that selected. The mean of the mean from the null hypothesis is 98.6. So that's what mu sub 0 is. X bar is the sample from the mean from the sample, which is 98.29. And then the standard deviation from the sample is 0.97. And the sample size is 55, so I'll just leave that. And the last thing to check here is what type of test we're using. So we decided it was two-tailed because of the not equals, so we'll check that box and press calculate. Now, the items that come up here, T is our test statistic, so negative 2.37. And the next thing that shows up is the p-value, so 0.0214. And I'm just rounding to the number of decimals I think is appropriate, but of course follow your rounding rules given in the problem. Now, a decision. Do you reject the null hypothesis? So effectively we need to do the decision. To make the decision in a hypothesis test, we take our p-value, the one that we just came up with, so 2.14%, and we compare it to the alpha level, so that's the level of significance, which is 5%. Now the p-value is less than alpha, And when the p-value is less than alpha, the rule is if p is low, the null must go. So we are going to reject the null hypothesis. So we can throw out either answers here that say fail to reject. Okay, so C and D are out. And the first two do say reject, but the second one says because the p-value is not less than the significance level, and that isn't true. So A is the option that we want in this case. So we reject the null hypothesis since the p-value is less than the significance level. So that's our decision. Then we come down to the interpretation. And when interpreting hypothesis tests, we have a couple of things that are different in each of these options here. So there is sufficient evidence to warrant rejection. There is not sufficient evidence. This one doesn't say, but I think it's implied that there is sufficient evidence here, and is not sufficient. So that's one thing that's different in each of these. The other is some of these statements have reject, and the others have support. And the last part is just a restatement of our claim. So there is some logic that you can walk through in order to make these decisions as to which one is the correct interpretation. But there's also an easy way of just memorizing a couple of facts. Like for instance, if you reject the null hypothesis, there is sufficient evidence of something. So if you reject the null, there is sufficient evidence to reject, or there is not sufficient evidence to reject. Sorry. If you reject the null, there is sufficient evidence to reject, or there is sufficient evidence to support. Regardless, there is sufficient evidence of something. So when we reject the null, we can count on that, which means we can actually throw out B because that says there is not sufficient evidence. And we can throw out D because it says there is not sufficient evidence. All right, which leaves us either A or C. And what happens here is if we go back to the original claim, we have effectively stated from the decision that we reject the null hypothesis. So the null hypothesis, the top statement, if we reject it, we're essentially stating that it's false, which leaves the other statement to be true. And so that statement, the alternative, also happens to be the claim. So if we're saying the claim is true, then we're in support of it. And that's kind of the logic of what's happening in the second blank, but you can also really just say, if the claim is in the alternative, you're trying to support it. If the claim is in the null, you're trying to reject it. So that means we can throw out A because we are not rejecting this, and choose item C in this case.